This video is on uniform circular motion and centripetal force. I will be able to understand the concept of uniform circular motion and centripetal force. We'll take notes from the video, find vocabulary, and discuss it with peers. So, uniform circular motion is motion along a circular path in which there's no change in speed, only a change in direction. So, constant velocity is tangent to the path, and constant force is towards the center. Is there an outward force on the ball? So the question of an outward force can be resolved by asking what happens when the string breaks. So the ball moves tangent to the path, so once it goes around, it breaks and then it goes off onto a side, not outward as might be expected. So when central force is removed, the ball continues in a straight line, and this is called centripetal force. So, an example of centripetal force: when you're sitting on the seat next to the outside door, what is the direction of the resultant force? Is it away from the center or towards the center? So when we go around a curve, force on you is toward the center. So, deriving central acceleration. So, our initial velocity at A and our final velocity is at B. So to find this, our centripetal force or acceleration is the change in velocity over time. So understanding that these are similar triangles, we get to the final formula that centripetal acceleration is v squared over the radius, and we have centripetal force equals to mass times centripetal acceleration, which is the same as mass times v squared over the radius. So here's our first example. If a 3 kilogram rock swings in a circle of radius 5 meters and its constant speed is 8 meters per second, what is the centripetal acceleration? So we already know that centripetal acceleration is v squared over the radius, and the mass is 3 kilograms. So if we know that the radius is 5 meters, the velocity is 8, all we're doing is putting it into the equation. So mass times v squared over the radius. So in this case we have 3 kilograms times the velocity, and that gives us the centripetal force of 38.4 newtons. Example 2. A skater moves with 15 meters per second in a circle of the radius 30 meters. The ice exerts a central force of 450 newtons, so what is the mass of the skater? So to solve all this, we know that force is mv squared over r, and so we multiply F times R, and it gives mv squared, and we're looking for m, so we have to divide by v squared. So using our numbers, we have mass equals 450 newtons times 30 meters over 15 squared, and that gives us 60 kilograms. So car negotiating a flat turn. So the centripetal force is that of static friction. The central force and the centripetal force and the friction force are not two different forces that are equal. There's just one force on the car. The nature of the such force is static friction. So how do we find the maximum speed for negotiating a turn without slipping? So our centripetal force is equal to our static friction. So the car is on the verge of slipping when the centripetal force is equal to the maximum force of static friction. So we have our three equations here. Static friction, again, is the coefficient of static friction times the mass times g, which is 9.8. So in this case, we know that the m's can cancel, so we're left with v equals the square root of the coefficient of static friction times 9.8 times the radius. So do keep in mind that the velocity is the maximum speed for no slipping. So here's example 4. A car negotiates a turn of radius 70 meters When the coefficient of static friction is 0.7, what is the maximum speed to avoid slipping? So we have a centripetal force, mv squared over r, in which case we get the force, or static friction force, and we have the coefficient, mass, 9.8. So when we put these all in there, we end up with a velocity of 21.9 meters per second. And that's it. So this is our preview in the centripetal force. Make sure you get the vocabulary cards.